Problem 7b is probably the most complicated problem in the vector projectiles Phet lab. I wanted to walk through an example of this to help those of you who are getting stuck because the algebra can be a little bit complicated. We're working with the case of a 60-degree angle. We have an initial height. Let's say the initial height is 3 meters. You need to use your own height that you chose. And the height of the target is 5 meters, and it is 100 meters away. And we want to know what the initial velocity will have to be to go that distance. So we're going to separate this into horizontal and vertical, as we've been doing. Acceleration horizontal is 0. Acceleration vertical, negative 9.81. Initial position horizontal is 0. Initial position vertical is 3. Final position horizontal is 100. Final position vertical is 5. And we know the initial velocities, and this is where that hint comes in. The initial velocity horizontal will be the total initial velocity times the cosine of 60, and the initial velocity vertical will be the initial velocity times the sine of 60. If we do these out and do the sine and cosine of 60, the cosine of 60 comes out to 0.5. So this one will be 0.5 times the initial velocity, and the sine of 60 comes out to 0.866 times the initial velocity. Now we're going to set up our two equations. We'll first set up our horizontal. 100 equals 0 plus 0.5 v naught times t, so 0.5 v naught being the initial velocity, and the second part will be 0. So we get really 100 equals 0.5 v naught t. For the vertical, we get 5 equals 3 plus 0.866 v naught t plus 1/2 negative 9.81 t squared. Now we're going to have to use these two equations together as a system of equations. So I'm going to solve the first equation for the variable time. So I divide both sides by 0.5. I get 200 equals v naught t. So t equals 200 divided by the initial velocity. I'm going to then plug that in for t in the vertical equation. 5 equals 3 plus 0.866 v0 times 200 divided by v0 plus negative 4.905 200 divided by v naught, and that whole thing is squared. Now I'm going to simplify. Subtract 3 from both sides. 2 equals 0.866 times 200, 173.2. The v naughts here cancel, plus 200 squared times negative 4.905, which comes up to negative 196,200 divided by initial velocity squared. Subtract 173 from both sides. I get negative 171.2 equals negative 196,200 divided by v naught squared. I cross multiply and divide. I get v0 squared equals negative 196,200 divided by 171.2. 196,200 divided by negative 171.2. I get initial velocity squared equals 1146. Take the square root of that. And I get 33.9 meters per second. This is the type of math that you will be doing in the problem with your own data for original final height and distance. You should not use the same exact data that I used.